All right, so welcome everyone. Welcome to the second of a four-part series from imagery webinar series specifically for the Americas. If you guys were listening earlier, I was reading off some different countries that are represented here. Great to have different customers and distributors from the region alike. I got a great one for you guys today. Imagery management. It's going to be very much technical in this series. As you can see on the screen, I have Kurt Schroepy, who's the Esri business development manager for Esri. He also has his video on. Can I get a hey Kurt? There he is. We have Mark Romero and David Wright, who are going to be presenting today. Both solution engineers, very great at their craft. You should be able to see their email addresses, or actually Mark Romero's email address listed twice there. I'll update that on the outro before we finish this off. And my name is Milquiades Walter Rodriguez. I'm a senior solution engineer, and I do business development for the Americas region. I mostly focus on the national government side of the house. But for this and the rest of the webinars, we're going to be focusing specifically on imagery all the way across the different industries. So just real quick for you Spanish speakers on the call, esta llamada va a ser completamente en inglés. Sus distribuidores locales quizás van a poder traducir esta. Así la estamos grabando, así que voy a compartir esta llamada con todas las personas que están registradas en las llamadas, que tenemos casi 400, y también pueden compartir estas con sus colegas. So with that said, we're going to go ahead and get started. I'm going to pass the word over to Mark Romero.
Okay, thank you, Milquiades, and I'm going to go ahead and get started. I'm going to stop my video to preserve my bandwidth here, and I'll kick off my screen share. You guys give me a second. All right, Milk, I'll wait for your thumbs up to tell me screen share is good.
Good to go. Good to go.
All right, we'll get started. Thank you. So today we're going to talk about imagery management. Dave and I will take turns presenting a lot of content today, and hopefully you guys will get a good sense of where we've come in different aspects of managing data. Just a couple bullet points of some terminology that we tend to get into when we talk about using imagery in our platform. And so when I refer to raster formats, I'm really just referring to how the pixels are stored. So these are just things like GeoTIFFs, COG, JPEG, etc. Raster type, when we use the word raster type, we're just referring to the metadata that can be read and used for processing. And so it's a term that we use within our system that allows Arcgis to distinguish what sensor you're working with. So for example, it knows if you're working with Landsat 8, it knows if you're working with WorldView 2, etc. Raster function, these are just image processing capabilities. And when we refer to raster functions, we're talking about on-the-fly processing of pixels. The Mosaic dataset, we'll get into this quite a bit. This is essentially the data model for managing large collections of imagery. It's stored in a geodatabase, and we'll refer to that quite a bit during the presentation. And then finally, image service. And so again, this is, we like to think of as another data model, but this is the way that an Arcgis client can consume that Mosaic dataset as a web service. Okay, so when we think about imagery data management, these are four ways to look at it, and think of these as four separate data models. And I'll just read from left to right. Arcgis Pro is our desktop GIS client, and this is heavily used in imagery, both for visualization, interpretation, analytics, but also just like viewing and bringing in all different types of imagery. So we think of Arcgis Pro as sort of its own data management tool. The Mosaic dataset, this is the data model that we use for managing large collections of imagery or raster data. And there's much more to this, but we'll get into this. But essentially, large collections lets you harvest metadata, lets you manage it in many different ways, lets you display it in many different ways, and also lets you serve that imagery out. when you're working with different types of raster and imagery. For point clouds, we have a different data model. And for those users that manage large collections of point clouds, this could be photogrammetrically derived, or it could be LiDAR derived. We have a layer called the last dataset. And similar to the Mosaic dataset, lets you manage those collections and much more. And then finally, the fourth one that we'll talk about today is something called oriented imagery. And this is a newer data model that we have for managing anything from oblique drone, oblique photos collected from a drone to any kind of street level data. So this could be photos from a smartphone. These could be vehicle mounted camera systems, that are driving, collecting, and taking pictures there. So, anything that kind of falls under a street level, we refer to that as oriented. All right, so these are the sensors that will be, and the data models we'll be referring to today. All right, I'm going to jump right into a story map to talk a little bit more about our system here. Okay, the screenshot over here on the right, I put this as my banner for the story map, and I like this one because it's a representation of some of the challenges that our customers are faced with when they have large collections of imagery. So this is actually a series of digital globe images captured over New Zealand. And you can see when you look at these thumbnails, they're all taken under very different conditions. Some have more clouds than others. They're all of different dates. And for those that are that have these types of images, like how do you manage this and how do you actually make sense of all this data? Well, that's just kind of one of the ways that our system can manage data. We're very good at managing large collections. So this is just satellite, but we can, as I mentioned before, manage all kinds of different types of sensor data. So elevation, drone, LiDAR, imagery, street level photos, and video, just to name a few of them. Over the last decade, we've expanded our sensor support quite a bit, and there's been a lot of investment in this. So if we kind of go back, traditionally we've been really good at managing satellite data, aerial data, somewhat recently drone data. But now we moved on over to the right, we can manage all kinds of different sensors. And so we're starting to see a lot of our customers with, for example, terrestrial LiDAR data sets, these camera systems that are vehicle mounted, and then also just people on the ground taking photos. And they want to integrate these types of sensors into their GIS. And so that's why we've expanded our imagery data model and sort of sensor support to be able to handle these different things. And that's really what this story map's all about. And I'll just start with satellite imagery. And of course, we can handle all kinds of different satellite sensors of all different resolutions with different metadata. We support over 52 different sensor models. And so the system is smart enough to be able to distinguish or understand the characteristics and the metadata of these different satellites. So it's actually a very powerful tool that we can understand that. Many of our users use multi-spectral imagery. And so here's just an example of a Landsat 8 image where we're switching between a true color RGB over a fire and a shortwave infrared band combination that actually lets us penetrate that smoke. In this case, get a better visualization of that fire scar. We have this term we use every once in a while, and we say when you're serving imagery or kind of cataloging large collections of imagery, you tend to generate a lot of different products from your sensors. So we have this term we use, store once, use many. So this is really like a data management and storage term. One of the benefits of using our system is if you want to generate these different types of products, as I scroll through, you don't have to reprocess, create a whole new set of images and restore that. This concept of on-the-fly processing lets us very quickly generate new products where it's just accessing the original data source and not restoring or reserving out. So this is actually a very powerful concept, especially when it comes to storing large collections. Moving on, what's becoming also very popular is the ability to work with oblique satellite imagery. And so over the past several years, we've been improving the support for working with oblique satellite images and aerial and drone oblique imagery. And so from the perspective of an image analyst, they may not want to see the imagery stored, or I'm sorry, the imagery viewed with north up. It's often better to visualize this as it was seen from the sensor, and we call that image coordinate space. And so you'll see a little bit of that in the demo today, but here's an example over San Francisco, just a beautiful view of downtown. We're orienting the imagery as it was seen from the sensor. And so from the image analyst or interpreter's perspective, it's much easier to visualize. All right, so moving on from satellite to aerial. This is an area in Houston. So just so many use cases for aerial photography. I've bullet pointed, listed a few of them, but primarily for base maps, but great for distance measurements, area calculations, great use in urban planning, asset management, and engineering. And so here's just a really nice example of our partner Nearmap, some high resolution aerial imagery over the Houston area. And so for us at Esri, the Living Atlas content team using it to update all the building footprints for our base map content. And we're using this also as a kind of a QA/QC tool to make sure our building footprints align correctly over the aerial photography. Yeah, here's just kind of another example of using aerial photography. This is an example of an interstate corridor. And so this is just cached imagery. We're primarily using this as a background, but very much a typical use case of imagery is to cache it, store it on a platform like Arcgis Online or Enterprise. It performs great. You can overlay all of your layers on top of it, and just beautiful to look at too. One of the sort of requests that we've gotten quite a bit over the last few years as drones have become popular is the ability to work with oblique drone imagery. And again, just like the satellite example, we can do the exact same thing. We can orient that drone imagery so we can view that you know, in a much more easy to visualize interpretation. So here's just an example of some vehicles, high res. All right, so we're just kind of drilling down to lower resolution, or I'm sorry, higher resolution with some drone examples. This is actually in Redlands. This is our new building, building E. Oops. Sort of jumped on me there. There we go. And so just kind of scrolling through, and you know, many of our drone users are capturing imagery or flights over the exact same area, and for the purpose of monitoring and inspection. And here's just an example of high resolution drone imagery as we've constructed this building in Redlands over time. And this one's actually quite outdated, so I think this building's getting close to completion. And then just kind of the same thing here, but instead of the orthos from the drone imagery, we're actually just visualizing the digital surface model that's being constructed from that drone process. And then we can take that information, and then with Arcgis Online and Arcgis Enterprise, we have custom apps. We could just feed our 3D or our 2D content into it and have a nice visualization or a nice experience like this. So we've got the textured mesh on the left, and then we got the associated point cloud over on the right. So just two different ways to visualize the imagery. And then in addition to that, the ability to take these point clouds and work with the different renders. And so here we're looking at the mesh, but I'll go turn that off. And I can look at the point cloud either as true color or as elevation values, or even classified as ground, building, or vegetation, as you can see here. And then here's one that's you know, somewhat useful. I've seen these 360-degree oblique drone views used for disaster response. And so what this actually is a number of photos that is stitched together to get this, what appears to be a 360-degree panorama view of this area. And so this is all part of the site scan drone collection set of software that we have, and I think you guys will have more on that in a different session. Okay, so a lot of those examples are drone, but we can also work with any kind of LiDAR-based point clouds. And this one's not loading, so we'll just go ahead and move on. Okay, and the last example here, this is an example of oriented imagery. And so this comes from one of our partners, Cyclomedia. They've got a vehicle-mounted camera system that they drive along and take photos as they are driving. And so I'll just go ahead and full screen here. And so what you have is the map. You have all these blue points that represent where the vehicle is taking a photo. And then you have this triangle that represents the field of view. And then while I move that triangle around, you can see that the actual photo is moving along with it. And so I can expand that and just get a visualization of just the photo itself. And so we can interact here. I can actually click on to the next point if I want, and that'll move the camera orientation up a spot. And then we can move around. As if you notice, as I move my cursor around, I'm actually placing the cursor on objects. So with the system, it's actually object aware. And so they're actually performing some photogrammetry in the background where they're generating a digital surface model. And that's how we can kind of move our cursor. And so you can imagine all the different use cases up here, but primarily we have this ability so we can actually collect points within the city, all from this app, and that'll populate our existing GIS. Okay, elevation data is another popular type of sensor that our users are using for a variety of reasons. And so in this example here, I've got a digital terrain model. This is global. And if I want, I can quickly change the renders of that. So we'll do multi-directional hillshade. And so this is really what we're referring to when we say on-the-fly processing. So I have this stored once, but I can generate a variety of different products just simply by selecting that render. And this all happens on the fly. For those of you that have video feeds or video content coming from aircrafts, our full motion video product supports MISB compliant video feeds. This also supports drone imagery. There's a little bit of work that has to be done to make sure that the system understands the metadata that's coming off of the drone. And so those are just the orientation parameters that are captured from the drone itself. So these are things like yaw, pitch, and roll. And so as the aircraft is flying along, we can see that video feed from there. And then we can also see the extent of the video frame onto the map or the surface here as it's flying along. Okay, so I just wanted to start off by giving you guys a sense of all the different types of sensors that we support, and all the different ways you can kind of publish those out and consume those. But the question is like, how do you get there? For the most part, a lot of that authoring and management all starts from Arcgis Pro. It starts from the desktop side of things, and that's really what I want to transition over to right now. So for those of you that have used Pro before, it's a contextual desktop-based application with a ribbon interface. And when working with imagery, it understands what imagery is. And so it's very contextual. So there's actually a dedicated imagery tab. And so here's just kind of an example of our ability to toggle between a geographic projection and reorient that to view it in what we call image coordinate space. So here's an area in Rio. You can see north up. The image looks very disoriented. I can click a button in the table of contents, and that's going to reorient that image. So now we can see it, sometimes referred to as top up. So much easier to interpret from the analyst perspective. Okay, so that's just kind of the pro interface, just a little bit of ways to visualize that imagery. And I'm going to reset this story map. It's not playing the current video. Apologize for that. Okay. All right, so how do we get imagery into the system? There's actually quite a few ways. You can actually just take it from your desktop. You can drag the image right in, kind of like what you're seeing here. You can also use the catalog pane, and you can just navigate the folder structure. You can drag and drop right into your map. And then if you're old school, if you like kind of the old way of doing things, you can use the Add Data button and navigate to it that way. You can also take a REST endpoint, and there's an option in there to add from path. So I listed 3, but there's actually 4 ways to add data into this. Yeah, so we've made it easy to just be up and running with your imagery with a variety of ways to actually get that into the system. As I was saying earlier, Arcgis Pro is contextual, and there's a dedicated set of tabs just for working with imagery. One of them is called the Appearance tab, and this lets us easily change band combinations with a drop-down. So in this case of the Landsat 8 image, we've already detected some of the possible band combinations. And with one drop-down, we can just select that one. We also have image enhancements, so we can change the brightness, change the contrast, even change the gamma stretch here. We can also change the symbology, and then we can also change the stretch type here. And within the symbology panel, we can get rid of these no data values simply by identifying what that no data value is. In this case, it was 0. And then if we want to apply some transparency, perhaps do a swipe, all those tools are built right into the ribbon interface from the Appearance tab in this case. Okay, I showed this already, so I'll just go ahead and skip this one, but this is the image space versus coordinate space. It just kind of had that hiccup earlier. Okay, so how do you create these Mosaic data sets? One way to actually think about what a Mosaic data set is to think of your own drawer that you have full of photos. So, I've got in this example here, you have a bunch of photos that we've kind of just stuffed in a drawer or someplace. What a Mosaic data set does actually takes all those photos and kind of think of it as a way to put it in a nice photo album, So it takes them, it organizes them, it reads the metadata, and just gives you a better way to organize and visualize and use that data. But it's really much more than that. There's advanced processing, querying, selection. We can work with the metadata. We can perform GP and all kinds of analytics against it. And then ultimately, what it's designed to do is also to distribute and share. And so it's really the heart of a dynamic image service. And so the way that you create these is actually quite simple. So I'll just kind of let this play through. Let me actually reset that. Okay, we'll just kind of let this play through. But so we start within ArcMap. We create a geodatabase, and once we have that geodatabase, we can create a Mosaic data set from there. Now, when we add data to a Mosaic data set, we're never actually copying imagery into the geodatabase. We're actually just referencing where that data exists on disk. And so we believe that you should leave the data in its raw form as is on disk, and then just point to it or reference that. And that's really what a Mosaic data set is doing. The storage options can be anywhere. It could be local. It can also be on cloud storage. It could be on network storage device, or anywhere you want to store it. So here we are, kind of starting from the beginning here. Right-click that geodatabase, give it a name. You can actually define a product definition. So in this example, we're working with some planet imagery. We have those 4 bands defined. There's our empty Mosaic dataset. We'll go to right-click, add rasters. We'll point to the raster type and actually specify what type of sensor this is. And then we'll point to a folder where all that imagery exists. Check on a few parameters and then just hit run. And so what that is doing is crawling that folder. Any planet image that falls within that folder is then added. And so each one of these green footprints represents one scene that's been added. And there's some other interesting tools that we can do to kind of populate this thing. In this example, we're just actually getting rid of all images that have a significant amount of cloud cover. And you'll see when we run that, it'll sort of limit how many images we've added to this Mosaic data set. So that's really like the basics of creating a Mosaic data set. There's different workflows for each type of sensor. If you're working with elevation data, that's going to be a slightly different workflow, just considering what kind of data it is. If you're working with pre-processed orthos or aerials, that might be a slightly different workflow, but this is kind of just one example of using planet imagery. All right, so that's Mosaic dataset creation. Okay, another set of tools built into Pro is a way to kind of sort and work with the actual images when you have large collections. So in this example, with the drop down of the sort from the data tab, we're just putting all the cloudiest images on top, and then or the cloudiest images on bottom. Or if we want the newest image on top, we can drop that down. And all it's doing here really is just referencing the metadata from the acquisition date field that's built into the footprint layer. And so it's utilizing that metadata that comes with this type of sensor to be able to do that. So it's actually pretty powerful, but just an easy way to kind of sift through and get to the image that you're looking for. More recently, I think a couple of versions ago, we introduced a better way to do search and discovery against Mosaic dataset. So from the data tab, there's a tool called Explore Raster Items. And we can go into this panel and we can actually search for the different types of products that we want. Again, depending on what metadata you have, will determine what options you have to sort of sort through. In this example, we're actually just sorting by object ID. We'll show the thumbnails to give us an idea of which image we are looking at or interested in. And so you can see those listed on the right. And then we can actually load each one of those directly into the map. And then treat those as individual images. And so this is, once we kind of narrowed down what we want, it just makes it easier, more usable. So we can turn off the Mosaic dataset. And now we have the 2 images that we're interested in working with, excuse me. Okay, so once we have those 2 images, what can we do with it? We'll get more into analytics next week, but this is just a little bit of kind of an introduction into Raster Functions. And so Raster Functions, as I mentioned at the beginning of the presentation, are image processing tools that let us perform different types of analytics. In this example, we're just creating an NDVI for both images. And so you can see very quickly, we've generated a new in-memory product very quickly. And so we can do actually much more than that. We can actually take these function chains and we can create really complex models, do things like change detection. And as we chain these different functions on top of each other, we can make a very complex model. And so in this example, we're going to do an NDVI on the 2 images of 2 different dates. And then we're going to calculate a basic image to image difference just to get an idea of where there has been change in vegetation between the two dates. And so here we're using a raster function called the raster calculator, and we're just identifying what those variables are for each one of those images. So we got a T1 and a T2, so then we're just going to do an expression where we subtract T1 from T2. And so what that does is it gives us a change layer based on NDVI values. And then we can actually take that, we can composite this into a 3-band product. And then we can apply a color map on top of that. And so really the point of this is just to kind of highlight where that change has been. So the magenta colors represent where there's been a decrease in vegetation, and green represents where there's been an increase in vegetation. And so we can actually load that model and view that chain in a visual representation. And so for those of you that have used Esri before, you can see that very much looks like a model builder, but it's actually not model builder. These are all, as I said, these are all raster functions that we're chaining on top of each other. But a similar idea, an input data set, or an analytical tool, then we get an output. And then so we can take that chain, we can actually save it, and then reuse them over and over and over. So it's a great way to go through a workflow as you're getting more imagery in without having to kind of reproduce and create these things. And then we can take these raster function chains, we could attach them to the Mosaic data set, and then we can push those up as an image service, and then those get carried along the way with them. So yep, that's pretty much the kind of the workflow of taking raster functions and then chaining them on top of each other. This is just a little bit more to expand on how you can take a raster function chain and you can actually on the fly edit this thing. And so think of this as kind of your, QA tool where you may not get your analytics right the first time. But what's great about these is you can quickly change a parameter, invoke it, run it, and that on the fly in memory creates that product. Instead of running this and actually writing out or persisting a whole nother layer to disk, and then you realize it's not right and you got to kind of go back. And so here you're not filling any hard drive space, you're just quickly generating the products that you want. Yeah, so just another advantage of on-the-fly processing. Okay, so as I mentioned, once you take those chains, apply them to your Mosaic dataset, you then have access to them through this processing templates dropdown. And so that's nice. As I was saying, you can make these really complex chains, attach them to your imagery, and you're not going to have to go and reproduce that. It's just there. It'll on the fly create that product. Okay. Okay, some of the tools that were released, I think 2 versions ago was our charting tools. And so in this example, we're just doing a basic spectral profile of a Landsat image. And so within the map here, we're clicking a point, in this case, water, and then you can see that spectral profile. So you can actually see the wavelength information on the x-axis and then the value on the y-axis. And so, what we'd expect to see from water, probably very low along that line there. The next one is just probably some sort of field. And then, of course, we can go in and change the colors of each profile just to distinguish them from each other. And so you can see vegetation is going to have quite a different spectral response than water. And so you can see it's very high in the near infrared band. There's an empty field. And then we'll do one more here of urban. Yeah, so this is just these tools. The charting tools are about interpreting your imagery, trying to figure out where there's anomalies, and just getting a better sense of, getting a better idea of the pixel ranges and the pixel values, and identifying things you might not see by the naked eye. It's a great way to interrogate your imagery with these charting tools. Okay, we're going to get into kind of the whole publishing of imagery a little bit later on in this presentation. Dave will cover a couple of them, and I'll cover a couple of them as well. But I did just want to highlight Pro is very much a tool that's commonly used for publishing imagery. And so in this case, we're just taking that Mosaic data set that we created earlier. We're connecting to our Arcgis Enterprise, and we're simply analyzing it and then publishing it up to the web as a REST endpoint. And then once that data set is actually published as an image service, we can click our portal button or our Arcgis Online button here, and we can actually see that item or that layer directly in the catalog pane and just drag that right in. So when you publish a image service, you can also think of Pro as another really good client that can access those image services. And all those processing templates that we created from the chains get carried along with it. And then we have that almost nearly exact same experience with working with local data, but in this case, streaming from the web as an image service. And then, of course, we can take that same image service and we can view that in our enterprise or even our Arcgis Online account. We can load that right into the web map and do very similar workflow. In this case, again, we're just kind of switching between band combinations, but you can see the idea here. We're taking imagery, we're authoring it as a Mosaic data set, we're managing that metadata, we're creating these different processing chains that generate different products. We can visualize it in all kinds of different clients, web, desktop, you name it here. So you can see how all these pieces kind of come together. Another part of Arcgis Online and Arcgis Enterprise is our ability to do analytics, but not from the desktop side of things, but actually from the web. And so here's an example of a web application configurable app. And so these are built into Arcgis Online and Arcgis Enterprise. Once we have our imagery up there, we can utilize these templates to do some different types of analytics. So in this case, what I'm going to do is perform an NDVI and then do some thresholding where I can actually query different types of NDVI values. So I've specified my infrared band and my red band. And then I can quickly on the fly generate what those healthy vegetation pixel values are. So what's happening here is as I move the slider up and down, this is server-side processing. So it's actually sending a request to our image server, and then it's returning those values. What you're going to see, I think, from Dave is we have now the ability in Arcgis Online to actually do client-side image processing. And so this is a new capability that's coming out probably Q1 2020. I'm sorry, 2021. And so Arcgis Online will have the ability to serve imagery out natively. And so we'll get into that here in a bit. Okay, I'm going to switch to Pro, and then I'm going to show just a couple things that I wasn't able to show in the story maps there that are somewhat new. Okay, so here's that same Landsat image. I'm actually going to go to a bookmark here, just zoom in. And so right now I'm displaying the multi-spectral image. This is an 8-band image that I've got stored locally. Again, if I wanted to just quick change the band combination, I could go to the Appearance tab and then just pick any one of these that I feel like shows the kind of the the product that I'm interested in. So I'll stick with color infrared in this example. Another one of the really interesting and useful charting tools that's available is the scatter plot. And so if I right click the image, go to create chart, I'm going to select the scatter plot tool here. And I'm going to move this aside. And what I want to do is actually see the range of values, or basically a plot of two different bands. So for my x-axis, I'm going to select the near infrared. And then for my y, I'll do green. Actually, I'm going to redo that. That's kind of a user error there. So let me select scatter plot. I'll actually draw an area of interest. Just for the sake of the demo, I only want to query a few pixels. So based on this area of interest, I'm going to query those pixels based on near infrared. And again, we'll go green. And what that does is it plots all the pixel value ranges from within this bounding box for the near infrared band on the bottom, and then green on top. And so why would I do that? And so one of the things that I'm interested in here is maybe in a future process, I want to like mask out the clouds, or I want to kind of identify what the pixel ranges are of a certain type of maybe near infrared value like healthy vegetation. And so I see this pretty unique pattern here. And so I can actually use the tools here, make a bounding rectangle, and select just those points that kind of fall within those two ranges. And you can see as I select them, they're actually highlighted in the map as well. So for whatever reason, the clouds are being highlighted. And so that's just telling me that clouds have a high spectral response on the green band and a high spectral response on the red band. I can probably guess that these ones down here with the high infrared, low green are going to be healthy vegetation. And so you can see as I kind of select those, it's highlighting some of those healthy vegetation areas. So this is, again, just another tool that we have right here in the desktop side to be able to interpret and just identify and kind of get familiar with your imagery before you actually start performing analytics on it. Okay, we're going to kind of completely switch gears here, and I'm actually going to show you how we can work with imagery stored in the cloud. And one of the abilities we now have within our product is cloud storage connection. And so within the Pro interface, I can go over here to this Insert tab, and I can hit this Connections dropdown, and I can actually connect to any kind of storage provider. So we support a variety of different cloud platforms. So you can see them listed here: Azure, Amazon, Google, Alibaba, and Web HDFS. So I can enter in my credentials. I would put a bucket name, and then I would put my secret keys, secret access keys, the region that I want to connect to, and then just hit OK. And then what I get is a list of all the places that I've actually connected to. And so here is an example where I've connected to an Azure blob storage. And then I have a cloud raster. Basically, it's a multi-dimensional net CDF that we converted to CRF. You can actually just kind of drag and drop that right in. And so keep in mind here, we're actually streaming this directly over the web. Right from cloud storage. This is a great data management tool as well for those of you that are considering moving your data to the cloud. There's no issues with directly connecting to that information right within the Pro document itself. So, and so we'll see how good my internet connection is here. And so while that's going, if you're not storing your own data, but you want to connect to some of these open data repositories, for example, AWS has a large data repository. You can get everything from Landsat 8 to Sentinel-2 to Sentinel-5, and they provide the connection information here. Here's an example of Sentinel-2, and then here is Microsoft Azure's open data repository. Again, you can get weather data, MODIS, NAPE, and a variety of different others, and they provide all the connection information in there as well. From the Arcgis Pro side of things, connecting to these is actually super simple. So I'll just show you an example of how you do that with Sentinel-2. So go to the page. This representation, this character represents the name of the bucket that you would connect to. So all I have to do is just simply copy and paste this bucket name. I'm gonna go back to Pro. I'll hit connection and then hit add cloud storage connection. Oh, I'm sorry, I'll go new cloud storage connection. I'll just give it a name. I know this is from Amazon, and then I'll just paste that name right in there. And since this is publicly available, I don't actually have to enter any secret keys or secret access keys. But I do want to specify the region. So in this case, it's EU Central 1. So I'll make sure I specify that. And I believe that is Frankfurt. Let's see if we get lucky here. All right, so now if you blink your eye, you missed it, but I now have this new entry in here. For Sentinel-2, where do we go? I might have gotten the region wrong, but I've kind of preloaded one of these, but you can see now that I can access that directly here. So and you can see all the different folder structures that they have. And then again, I could just navigate to the one I'm looking for and then just drag that right in. They have somewhat of a complicated folder structure here, but and so this is actually a JSON file. I kind of navigated to the wrong one, but yeah, once you're familiar with kind of the way that these different providers organize their data, you know, you can just kind of navigate. But yeah, very easy way to, without doing much, you just simply make that connection file and yeah, directly connect to some of these data sets. So let's see if I can actually find a different one here just to prove out that it works. And yeah, so here's a cloud optimized geotiff. Again, I'll just kind of drag that right in. And so there is a little bit of, you know, once the image is loaded into the map, it is using some of your local caching default settings that you have set up with Pro. And that's by design, and we want you to have good performance when you're streaming data over the web. So this is going to make it easier to work with the image itself. So yep, you can see that image that we just loaded in, just like that. Okay, so that's just a little bit of cloud storage and how you can access data from your own cloud storage or how you can connect to publicly available stuff. Dave's going to go into Living Atlas of the World. So we actually do provide a lot of these data sets for you already kind of pre-configured. Dave's going to talk a little bit about that. I'm going to finish up showing you some capabilities that are part of Arcgis Enterprise. And so a lot of what I've shown is, you know, very much desktop heavy. So we also acknowledge that not all of our users, imagery users, are going to be savvy or proficient in the desktop software. And so we've actually made the ability to create image services available in Arcgis Enterprise. And so if you click your content button, assuming you have an image server set up and you hit this create button, you'll see a new option here called imagery layer. You can click that, and then this just gives you a nice, simple user interface experience for creating your own image services. So we've got quite a few options here. The one that I'm choosing is we'll take many different images as an input and then mosaic them together. I can create a dynamic image service. I can also create one image representing one layer. So if I have 10 images, this would create 10 different layers if I wanted to do that. And then I'll hit next. And then I'm going to specify the type of raster type that I have, in this case, netcdf. And I've got two options here. So I can either browse to a local image, or I can actually set up my system so it directly connects to cloud storage as well. So that's kind of a nice option from the enterprise side of things. So for this demo, I'll just browse local and paste this in. All right, so I got a netcdf layer representing temperature that's global. And so I select that raster image that begins an upload. I can go ahead and just enter in all the necessary attributes that I need. I'll just paste these in to make this quick. All right, and then hit create. And that's really it. And so once the image is uploaded, it'll do all the necessary kind of back-end processing that it needs to do to create that image service. And so there's a lot going on in the background here. The data is actually being stored wherever you specify it to be stored. And so we call these things raster stores. The advantage of defining your own raster store is that you can decide where you want this actually stored. So in my case, I have an Amazon S3 bucket set up as the raster store. So as I upload imagery here, I know it's going to go to that location. And so I can always manage it there. I never have to worry about actually filling up any kind of hard drive space. And so that's kind of a nice, nice option there. So we'll let that load. I don't know, it shouldn't actually take too long, but just for the sake of the demo, I've already done this before, so I'll just go ahead and open up the map. And then also here's the one that we just did. Here's the one I did earlier. So we'll load that right in. Yep, and just like that, we can generate our own image service managed by our enterprise with full capabilities to do analytics on them. Okay, I'm gonna go ahead and conclude my demo there. I'm gonna stop presenting, and Dave, I'm gonna pass it over to you, and I'll have him take it away. All right, Dave, can you hear us?
Am I unmuted?
There you are. Yep.
Okay. Thanks, Melquiades. And thank you, Mark. Hola, buenas tardes, everybody. My name is David Wright, and I'm just going to take you through some additional live demonstrations that touch on some of the topics that Mark has shared with us. So let's see if I can share the correct screen. Give me a thumbs up when you see it, somebody.
You're good to go.
Yep.
Thank you. Okay, so before I get into service enabling imagery, I wanted to just mention how important it is, all of the content that Esri makes available through the platform. And that kind of starts from the side of curated and authoritative data. We have the living atlas of the world. We've seen some questions come across already about a lot about open satellite data archives like Sentinel-2 and Landsat 8. And so the Living Atlas of the World provides a deep set of authoritative content that is curated by data stewards who are closest to the data sets. And I just wanted to mention, if I search on a specific topic, this is one way on the website to actually just come in and look at all of the different kinds of imagery, how it's tagged, where you want to be able to search through the different categories. and get a full description on everything. So this is just one way of getting acquainted with the richness about that content. Another important way to understand this is through Pro, our users have this on tap initially through the base map settings. So there are dozens of these high performance cached base maps that you can load for typically for reference and spatial orientation within your projects and workflows. So you can choose a different map and decide what really brings in the most valuable information for your specific application. The other thing within Pro is the catalog pane, where we can select the portal tab. And here on the Living Atlas of the World, even just searching South America, we find hundreds of layers here that are specific to that topic. And you'll find the filter tool to be able to access those same categories that we were looking at in the web page. In addition to this out-of-the-box content for our users, you'll also find your organization, whether that's Arcgis Online or your own deployed Arcgis Enterprise portal. You can see what's available within the organization, within the groups that you have membership to, your favorites, or just your own content. So these are some of the ways that we can commingle that data and bring it into scope. So I'm going to go back to the Living Atlas and just do a quick search on elevation. We'll find a couple of key layers here. Terrain is actually the one that I'm going to use. This is a global service. Mark already identified for us within imagery services how we have this context menu available. And with data, I can come in, with data tab selected, I can come in and select from the processing templates. And I may want to take a look at the slope degrees, and I just choose that and see that classification come up for display. Or any of these others, perhaps a hillshade is more interesting in that context. So just a quick introduction to how to bring that content together from curated, organization, and other partner sources within desktop. Quick transition here to Arcgis Online. And I'm just using a web map, but it's really the same capabilities. You access the Add tab or the Add button and just choose if it's Living Atlas layers that you want. You can search for them here. You can click on it to get that descriptive content about who's providing the content and all of the details that you need to know. You can also just click on the Add button and bring that into your project. Here again, looking at your organization and your groups, it's all at your fingertips. This web map here mixes content from the Living Atlas of the World, including the Sentinel-2 views layer. We've got real-time meteorological data that we can animate. And I'm going to spend some time now just talking about imagery here within the context of Arcgis Online. One thing that we can do is take advantage of the Sentinel-2 views layer, just change the image display. We can use some of the predefined renderers here as well. If I'm interested not only in this agricultural viewpoint, but maybe just color infrared. We can assign a stretch of different types. I'm going to choose % clip and do a dynamic range adjustment. So all of this is done on the fly and provides a great deal of content that you can bring into your projects. So I'm going to deviate from demos for just a moment. I'm going to go to a slide deck. I really want to describe for you, the deployment. If imagery has the importance of being service enabled in your organization or for your customers and partners, you may need to be looking at the deployment of Arcgis Enterprise. Some of the reasons we see commonly are there's just changes. It's either in the demand from your customer set or your internal teams. Could be changes in budgets or expectations. And sometimes people just want to be able to scale without a term commitment instead of having to commit to infrastructure as a service or local infrastructure. We can sign an agreement with a cloud provider. And those are typically ad hoc, so you can just spin up the resources that you need when you need them. Digital transformation is another big motivator on going to the cloud with your deployment. And Mark mentioned this, but data proximity is important. Where you're doing the compute and the analysis in your workflows is important to consider with where is your data. So you want to have good proximity to that. And in many cases, you can just be in the same zone as your data and have high performance, high availability services. So who can build this? You can have contracts with IT support and management providers. Esri has managed cloud services that can consult and do this. But what I want to emphasize today is you can do it. Local human resources in your own departments. We have a great deal of tooling that makes this simple to deploy on commercial cloud, whether that be Azure, Amazon, or anything else, frankly. Our team, the enterprise team, has put a great deal of effort into making this faster and easier than it's ever been, and making it simpler to deploy and even to upgrade. So the options include what some of you may have already worked with in the past, are setup installers that you can download and deploy on your virtual machines or in the cloud. We also have machine images that are available so that you can take advantage of that, save yourself some time in the configuration. And then there's a host of orchestration and automation tools that you can choose from. So part of the reason we like to use cloud builders to automate is you don't have to be an expert with cloud native technology, whether that be from netting and network or load balancers or configuring security around best practices in firewalls. All of this gets managed for you through a simple wizard-driven interface. I'm going to take some examples from Azure here in this case. A resource group really brings together all of the cloud resources that are available or that are put to work in the enterprise deployment. And it groups them so that we can see things like performance of the infrastructure and cost as it's being accumulated, or to make a trajectory about the cost for a period of time in the future. So here are some screens from that builder for Azure. It really just takes administrator feedback from the user and allows you to simply advance through the deployment, whether you have a single tier for your deployment or a dedicated multi-tier deployment with multiple sites involved to meet your demand. And this just shows the relationships, whether it's that single tier or multiple servers having a common relationship with file storage, data stores, and configuration data. So I'm not going to spend a great deal of time on this, but again, staying within the context of Azure for the moment, we used to have separate sites that had to be deployed in a V1 deployment. We've now supported Azure's application gateway, so you can have a single fully qualified domain name and all of your individual federated sites behind that. It just makes it more secure and simpler to deploy. And then you can scale up as you need to, as you go. If you find you need greater raster analytics or image capabilities like Mark has demonstrated today, we make that simple. So getting started is just get a subscription and then ask us about how to access the software and the builders. Right, so I'm going to switch over to some demos once again. And Mark showed us how you can as a publisher in desktop, you can manage Mosaic data sets locally. You can bring in enormous amounts of content and make that simple to use and consume in desktop, or to publish that out into an ArcGIS enterprise. So imagery has become pretty important with many of our users, and Mark showed us how we can publish in ArcGIS Enterprise an imagery layer. I wanted to highlight something that's coming soon here. This is Arcgis Online, and the idea of having an SLA imagery service is near at hand. I'm using it in beta right now, but it's a very similar workflow. I'm going to create an imagery layer and just choose the type. I can have tiled or dynamic, and as we step through, we can decide how we want the different layers of images configured in the output service. I'm going to use multiple images from one Mosaic service. And then here's the depth of Esri's knowledge about providers, partner content, and all of the different kinds of data understanding that we need to have. Configure the different processing templates, pan sharpening, and all the rest. And then really all we need to do is just choose that data structure, and ArcGIS Online understands how to accept that rich metadata and data structure from the content. So I won't advance through the wizard at this point. I'm going to instead just jump over to a web map with hosted imagery layers from ArcGIS Online. And here it may look like base map content that we've seen in other places, but it's actually very much an image service. And we can see that by the image display options. We can reconfigure our band combinations, or we can stretch that. To dynamic range and have the benefit of high performance and dynamic imagery capabilities. So one other thing that Mark touched on was the richness in creating web applications easily for your customers and for yourselves. I'm going to take an example of that web application builder framework that's making use of image service widgets. And it's called the Earth Observation Explorer. First, just from a global perspective, you can see that we have a variety of image services with millions of images included. These collections, I'm able to choose from either Landsat, Sentinel-2, or whatever you configure in your application. We can choose from bookmarks that are included or those that, that we may want to make for ourselves. And then what I'm going to do here is demonstrate that the renderers that we've been looking at are all advertised by the image service and made available inside of the application. So I'm going to switch to a more localized instance of this same application. I'm at the tri-border of Paraguay, Brazil, and Bolivia. And here, what I've done is to just select compare option in the widget. I've got an image on the left and one on the right. And what this allows me to do is not only just compare with the swipe tool on a web application, but to be able to search for individual images within those image services. This is coming from the Living Atlas of the World, as we looked at earlier. And I've chosen a very recent image on the right-hand side, and on the left one that's about a year old. So having the ability to compare is one thing, but let's let the machine do some work for us with server-side processing, and we can detect change between those two different dates. Let's look at a vegetation index and just apply that. The server is going to compute a change map and stream that to us in the application. And here what we see is in the magenta shades is where there's been a decrease in the vegetation index. And on the green hues, we're seeing an increase. You can change that to look at things like fire effects. And we can look at some of the changes that have occurred as a result of fire quickly and at our fingertips. And as Mark showed us earlier, if we wanted to draw a polygon and really focus in on a specific area, now we can just look at some of those thresholding capabilities and then dynamically have the ability to assist in the visualization of change and how sensitive some of these parameters may have become in your analysis. So I know we want to save some time to address questions at the end and answers. So I'm just going to finish with one last topic. Esri has a rich set of relationships with imagery providers. So in addition to the open catalogs that we're presenting to you for Landsat, Sentinel, MODIS, NAPE, and the others, we also have providers that operate satellite constellations. And I'm going to focus on one that we recently advertised our relationship with and some integration. This is their website, so it's giving me the ability to get very fresh imagery into the picture for analysis. I've got around me here in Colorado right now several major fires burning, so pretty tuned into this at the moment. And what I see from their website is that there have been collects over the recent days leading up until yesterday. But what I really want to focus on is back in ArcGIS Pro. I'm going to change over to the Planet Imagery add-in. And what this does is for subscribers of the Planet Imagery service, we're able to integrate search directly into the Pro environment. So here I've created an area of interest for my search. I've set a date time range from where I know the fire started. And I searched, and what came back are these results. Day by day, they're organized by sensor, by the pass, and then we have a quick way to look at the coincidence between those individual scenes and the fire area. I can see this didn't pass over the outbreak, but this satellite came right through the middle of it. And so what I've done is just turn that, I've selected these, and that adds a new layer group into my contents pane. I have individual control over those here now in the table of contents. And they're streaming to give me the full pixel resolution, and I can see the situation on the ground, or take that into an analytics story. We can even go back into the prior dates and see the difference between the progression of the fire at that time. So here I should be able to see, I guess it's on the other pass. Here we are. So this is where the fire started. And what I wanted to see is at an earlier point in the fire, how it had progressed. Looks like a good scene. And so here on the 15th, we're now able to see the early stages of outbreak and when it was still a smaller fire perimeter. So with that, Milkiadis, I'll hand the microphone back to you. And once again, thanks for your time and your interest.
Yeah, thank you for that, David. Thank you guys for sticking it out to the end. I'm now going to go over some of the different questions that we've gotten throughout. Let me go ahead and share my screen. If you will, also, I'm just going to put the action back on you guys real quick before I go over the questions. If you could just pull your cell phone out, just scan that QR code and give us a bit of feedback on this session, as Mark and David did a fantastic job on this second imagery webinar series focused on imagery management. All right, so I'm going to pull out a document I've been keeping for throughout this session. I'm going to read off some of the questions, some of the answers I've gotten back from the experts, and if they want to elaborate on those, I'll let them do that at this time. Also, if you have additional questions, go ahead and drop them at the on the chat. Be sure to use this time that we have with the expert. All right, so the first question that I'd like to address is there any plans to support videos from sensors upon vehicles on FMV? And the answer we got was yes. We're starting a real push on doing all sorts of AI exploitations on video feeds. Kurt, I don't know if you wanted to expand on that, or you feel like that covers it well.
Is the Milkiades, is the question around like drone imagery, specifically drone imagery working in full motion video? If it is, I can kind of elaborate on.
Yeah, go ahead. Go ahead, Mark.
So as of today, if you wanted to take drone video from a DJI, for example, and load that into full motion video, it wouldn't work right out of the box. And that's because the full motion video application is a tool that was designed for MISB compliant aircrafts. And so what that means is basically there's a ton of metadata that makes it makes that video feed MISB compliant, and it's collecting that information from hardware on board the aircraft, like high precision GPS, and IMU, et cetera. And so as the aircraft's flying and taking video, it's collecting all that information. So when you load that into full motion video, it just works. But with drones, by default, not all those sensors are on there and being captured. And so we have a way, we're working on a way in SiteScan, our drone flight planning app that'll allow you to tap into, for example, the DJI, basically the hardware that enables that aircraft to capture that information. And so that's just like a metadata field. And then once you have that metadata basically as a CSV file, you can bring that into a full motion video product, and it'll use the bare minimum camera model information that's being collected by that drone. So it'll actually be part of SiteScan out of the box at some point this year. I don't know when the release date is.
Now, to carry that a little step further, one of the things that we are working very heavily on is implementing GeoAI machine learning technology for